In number 3, we can see the function is fx equals to root over 4 minus x square. So for this function to be real, 4 minus x square either has to be equal to 0 or greater than 0. 4x minus x square cannot be lesser than 0, because if it is lesser than 0, then that means it is in a negative number. The square root of a negative number is not a real number, as we know. The square root of a real number is never a negative, is never a real number. It is an imaginary number. So that is why the condition for finding out the domain is that 4 minus x square always has to be greater than or equal to 0. So now we can rewrite this here. Sorry, my mistake. Now if we divide both sides by minus 1, then the sign changes. This is a condition of inequalities. Whenever you change the sign of one side, whenever you divide, or basically whenever you divide both sides by minus 1, you have to change the sign, because that is what's logical. Suppose x is greater than, just to explain you why we do this sign change, suppose x is greater than 5. Okay, that means if we change the sign, then this will be lesser than minus 5. For example, suppose x is 6, 6 is greater than 5. Now if we change the sign for both sides, then minus 6 will be lesser than minus 5, as we know from our knowledge from the number line, that minus 6 is lesser than minus 5. That is the whole point. That is, see how this logic fits. So whenever you change the sign of an inequality, you are always changing this greater than sign to lesser than sign, or lesser than sign to greater than sign. That is the whole logic. See how this logic fits. If x is 6, then 6 is greater than 5, and minus 6 is lesser than 5. So the logic fits. That is why we do this. Now coming back to our domain, we can see x square minus 4 has to be either lesser than or equal to 0. We can now break it up into a square minus b square equals to a plus b into a minus b form. Now we use the method of intervals. In the method of intervals, you have to plot these numbers, 2 and minus 2. These points are called the critical points. You have to plot these points. How do you calculate the critical points? The critical point is that point for which x minus x the expression will be 0. So in this expression x minus 2, if we put x minus 2 equals to 0, then x will be equal to 2. So 2 is our critical point. And similarly here, this will be minus 2. Why do we do this? Because the reason for doing this is the values of x can be really close to, never mind, even I am at a loss for words here now. But basically what you have to do is, you have to put x minus 2 equals to 0, and then x will be 2. That is our critical point. So for whatever value this expression will be 0, or the two expressions er moddhe any one the whatever values makes the two expressions equal to 0, that will be a critical points. And from the number line we start from the right. From the right we always start with the positive sign, then we alternate and then go like that for how many for any number of points that we have. Our condition was that the multiplication was that this expression for x minus 4 x square minus 4 has to be lesser than or equal to 0. Lesser than 0 means negative. এখানে negative আছে, that means the values of x lies in between these two numbers. So therefore x belongs to -2 and 2. Now note that I am using this bracket. This bracket means that I am including the values of I am including -2 and 2 in my answer, because the condition is either lesser than or equal to 0. For equal to 0 you have x has to be -2 or 2. So that is why I'm using this bracket, third bracket. The third bracket means I'm including the values of 2 and -2. If I use the first bracket, that means I am using all the values that are near 2 or -2, but I am not including 2 and -2 in my answer. I am including all those numbers that are very very close to 2, that suppose 1.9, 1.8, numbers like that, but I am not including 2 in my answer. That is the difference between these brackets.